Today we are going to discuss plus 2 physics practical. Now we can discuss the refraction through a prism. Can we move to the experiment?
Here, the aim of the experiment is to study the variation of angle of deviation d with angle of incidence and to find the angle of minimum deviation from ID curve. That means in this case we will increase the angle of incidence step by step and we have to find the corresponding angle of deviation. And by using this we will draw an ID curve and then we can find the angle of minimum deviation. That is the first aim. And the second one is to find the refractive index of the material of the prism. Okay, so that we can use this values of A and D for finding the refractive index of the prism. So these two are the aims of the experiment, and the apparatus required are glass prism, then drawing board, pins, protractor, graph sheet, etc. Okay, then principle used is only the necessary theory only we have to write for the principle. Okay, so here we have to mention the equation for finding the refractive index of the material. That is n is equal to sine A plus delta m by 2 divided by sine A by 2. Okay, here instead of delta m we can write capital D also. Okay, and A is the angle of the prism and D is angle of minimum deviation. So here we are taking the angle of prism as 60 degree, as this is an equilateral triangle. Okay, and by substituting the values of A and D we can find the value of refractive index. Before starting the procedure we can see how the ray diagram looks like. Okay, here we can see the ray diagram, that is the outline of the glass prism is shown here, and in one side we can see the incident ray with a blue color, okay, blue line, and there should be an arrow mark because this direction also we have to show the, and here we can see the angle of incidence I1, that is the angle between normal and the incident ray. So here this M is the normal, and from the glass prism we can see that a refracted ray, and after reaching this point N it should be going outside, that will be an emergent ray. So the angle between the normal and emergent ray is called the angle of emergence. And here what we have to do is we have to extend this incident ray and the emergent ray in order to meet at the point O. So that point is shown with an arrow mark. Okay, that extended part is with a dotted line, and that point is O. When we produce this incident ray and emergent ray in order to meet at O, we can see that there is an angle D, that is the angle of deviation. So that angle of deviation we have to measure. So first of all we will take a value, suppose it is 30 degree for incident ray, the corresponding value of the angle of deviation we have to measure. So that step by step we will increase the value of angle of incidence and then the corresponding angle of deviation we have to find. So that is the theory that is happening here. Now we can start the experiment. For that, first of all we have to fix a sheet of paper on a drawing board by using drawing pins. Okay, then we will keep the prism on the table and we will draw the outline of the prism. Okay, after that we have to remove it and draw a normal in one side of the prism as shown here. So for getting the normal, as we know we have to use a protractor, and we can keep it on the center of this line and then mark the 90 degree here. So that will be the normal, right? Then first of all we have to get 30 degree. Suppose it is 30 degree, that is the angle between the normal and incident ray should be 30 degree. For that what we have to do is we will again keep the protractor there, and from 90 degree we have to measure 30, that means 90, then 80, 70, 60. So on 60 we have to put a point and then join that point to get the incident ray. So that angle between the normal and the incident ray should be 30 degree first. Okay, now we have to keep two pins on the incident ray, and then we can keep the prism back to the position. Here we can see that we have kept two pins on the same line, that is on the incident ray, and the prism is kept here. Okay, now we have to look on the other side of the prism for getting the image. Here we can see two more yellow pins, that is on the other side of the prism. That means on looking through that side, we have to see the image of these two pins on the incident ray. That means that of green pins we have to see through the other side of the prism. Okay, and we will keep the third pin in such a way that three should be in a same straight line. And after getting that, within 1 or 2 centimeter difference, we will again keep the fourth pin, and it is compulsory to keep the fourth pin also. And when we are looking from the fourth pin, we have to see only the tip of the fourth pin. That means all the other three should be in the same straight line. Okay, this is how we will get the image when we are keeping all the 4 pins and looking from the fourth pin. Okay, so in that side we have to look, and then we can see that all should be in a same straight line like this. Now we have to mark the 2 positions of the pins on the other side of this, and then we have to remove the prism and then join the 2 points for getting the emergent ray. Here we are getting that emergent ray like this. Now we can draw the normal on the emergent ray also. So that angle will be the angle of emergence. So here we don't have to measure the angle of emergence. We need only the angle of incidence and angle of deviation. Now we have to extend the incident ray and the angle of emergence in such a way that it should meet at a single point, and then we will get the angle between these two as the angle of deviation. Now by using the protractor, we will measure the angle of deviation in each cases. Okay, then we have to write this observations on the tabular column. That is, in the first case we can see that angle of incidence and angle of deviation on the other side. Now we have to tabulate here. Here we can see the observation column. That is, in first case we have to write down the angle of prism. That is, here it is 60 degree because this is an equilateral prism. Right, now we have 2 columns, that is, first one is angle of incidence and the next one is angle of deviation. So suppose we are taking 30 as the incident angle, we can write it as I is equal to 30 degree, and the corresponding value of angle of deviation we will write here, and we will repeat the same procedure for 35, 40, 45, 50 like that. Okay, that is, by increasing the values of angle of incidence, we have to find the corresponding angle of deviation. Okay, and then we can see that as the angle of incidence increases, the angle of deviation will be decreased and it reaches a minimum value, and after that it should be increased. So that by using this we can draw the ID curve. Here, after writing the readings, we have to draw the ID curve. So the calculation is only from the graph. Okay, so for that we will take the angle of incidence along x-axis and angle of deviation along y-axis. Then we will get a graph like this. Okay, here we can see as the angle of incidence increases, the angle of deviation, first it was maximum, right, then it decreases and reaches a minimum value, and then again it starts to increase. Okay, so we will get the shape of the graph like this. So we have to draw it with free hand. When we draw the graph, we can select an appropriate graph and then note the value of minimum deviation. That means where we are getting the minimum value of angle of deviation, that will be the angle of minimum deviation, and that angle we will note, and then we can use it for calculation. Now we can do the calculation from the graph. Here we can write the angle of minimum deviation D. So that much degree we can write, and when we are writing that taking the readings, we have to make sure that the angle of minimum deviation is either 38, 39 or 40 degree, because here in refractive index only that value of D changes because angle A is a constant. Okay, so that will be 60 degree only. So depending on the value of D, the refractive index of the value varies. So we have to get it D value as 38, 39 or 40. Then we will get the correct value of refractive index. Okay. So after that we can substitute the values in this equation, sin A plus D by 2 by sin A by 2. Then we will get the value of refractive index. Now we have to write the result, and for that we have to mention that angle of minimum deviation and also the refractive index of material of the medium. Okay.
Now we are going to conclude the video. If you like my video, please like, share and subscribe. Thanks for watching.